Abbreviated lesson on heat and temperature, and there's going to be a little bit of thermodynamics in here just to make it a little bit shorter and quicker for us. To start out today, let's just consider a situation. Imagine you have a cup of coffee sitting on the table. Coffee is 90 degrees Celsius. The surrounding air is 25 degrees Celsius. And we had a discussion in class. What would happen if you leave the coffee for 5 to 10 minutes? What would happen if you leave it for 1 to 2 hours? Most people can figure out that the coffee will begin to cool down to where you can actually drink it in 5 to 10 minutes. But if you leave it for about an hour or two, it will actually cool down all the way to room temperature. Nobody would describe that coffee with the word cold at that point, but it will certainly cool down. And the cooling down is the phrase that a lot of people used here. And the question is, can you explain physically, scientifically, what exactly is happening to make this coffee cool down? In a similar situation, imagine you have a cup of soda sitting on the counter. Once again, the outside air is 25 degrees Celsius, but the soda is 3, almost freezing because of the ice in it. Again, the same question: what happens if you leave the soda out for 1 to 2 hours? Again, people understand that that ice will begin to melt. Once that happens, the soda at one point, and we'll talk about this more in a little bit, will begin to warm up. So a similar situation, but the soda is not going to cool down, it's going to warm up. And again, the question is, can we explain why that is happening? So I tell about these two. I start with these two examples because one of the first things we have to understand is many people will use the term, especially for the coffee, will use the term cooling down. And both of these cases are actually the same. They both involve transfer of heat, not transfer of cold. So using the term cooling down isn't exactly correct because there is no such thing as cold. The terms hot and cold are simply relative terms. We use them to refer to a temperature compared to our body temperature. And if we're going to learn about heat and temperature universally, we have to remove it from our human experience and apply universal definitions that fit regardless of the perspective. So there's no such thing as cold. We use the word cold to just describe something that is cooler than our body temperature, in fact, usually much cooler. We want to get away from relative terms here. But in both of these scenarios, heat is transferring. Well, what is heat? Well, the best definition for heat in physics is that it is, and another word for heat is thermal energy. Heat is the energy transferred between objects because of a difference in their temperature. Very important to understand a couple of things here is that the idea is that heat is transferred. Now, there's some very similar concepts that are going to be talked about here, but when energy transfers from one object to another, for instance, the coffee to the air surrounding, or the air surrounding into the cold cup of soda, the energy that is going from one place to another, that's what we call heat, energy that moves from one place to another. And that energy moves because objects have a difference in temperature. Obviously, if two objects are the same temperature, they will not exchange heat. And hopefully this sounds familiar to you. We talked about something similar when we talked about electricity as well. Similar process when we have transfer of electrons from a negative to positive. If two objects have the same charge, there will be no transfer there. Just like if they have the same temperature, there will be no transfer of heat. At its basal level, you need to understand that temperature, or heat energy rather, is based on vibrational energy of atoms. See, all atoms in all objects are vibrating. All atoms all over the universe, all molecules, all particles are vibrating. Even that solid desk in front of you, the atoms inside are vibrating. And one important thing you need to know right now is that how much or how fast those molecules vibrate depends on the temperature of the substance they are in. So we can see that in the GIF here on your screen. The lower temperature object has molecules that are vibrating slower, but the bigger vibrations are happening in the object that has the higher temperature. The higher the temperature, the faster, and the more random those molecules vibrate in that sample. So we said that heat transfers between objects of different temperatures. Well, the question is, which direction does that heat flow? And I use the word direction in quotation marks because we're not talking about up, down, left, and right in this case. What we need to know is that heat always flows or transfers from hot to cold, from the warmer object to the colder object, never the other way around. And never can you put a hot and cold object together and not have heat transfer from hot to cold. And this is all according to the second law of dynamics. And I'll make another video about that. The second law really is a very, very important law that undergirds almost everything in our daily life, our daily existence. And we need to understand the second law of thermodynamics here.